Hi, my name is Anshul Singh, and I have completed my MSc in Physics from Banaras Sundar University, and currently I am pursuing PhD in ionospheric physics. So today we'll learn about angular momentum. So now I have a particle with mass m and moving with a velocity v. So it has momentum p. Momentum is defined as mass times velocity. So now this particle is situated at r radius vector r from a point O, which is our reference point. So so angular momentum is defined as with reference to point O. Angular momentum is defined as radius vector with reference to point O cross linear momentum vector r cross p. So this can be also written as r cross m v, which can also be written as m r cross v. So so we see that angular momentum is defined with respect to a point, and the unit of angular momentum is equals to m for kg meter into meter per second, which is equals to kg meter square per second. So the direction of angular momentum is given by right hand thumb rule. That is, since L is defined as m r cross v, and suppose this is my direction of velocity vector, okay, and from this point I want to calculate angular momentum O point, and my radius vector direction is this. So I'll just extend my radius vector so that both vectors are starting from both vectors, I mean velocity vector and radius vector are starting from a common point. So then so the r cross v direction will be like you place your hand on the radius vector and curl your fingers towards the velocity vector, so like this. So the direction of angular momentum r cross v will be perpendicular to the plane of paper and going inside, and this is also denoted by this symbol. So now we'll take an example. So suppose I have a reference frame. This is my x-axis, this is my y-axis, this is my origin. So now suppose I have a penguin. Suppose I have a penguin. Suppose I have a penguin. I'll just make a penguin. And this penguin has mass m and falling vertically with a velocity v and mass m, and this at any point, this is at radius vector r from the origin, and so now we have to calculate the angular momentum of this penguin with respect to point O. So I'll just write it now. So as we have defined, angular momentum is equals to r cross p, or can also be written as m r cross v, because p vector is equals to m times v vector. So from which can also be written as m r into v into sine of theta, because a vector cross b vector is equals to a is defined as ab sine of theta, right? So this, we can arrange this whole thing, and we can also write as mv into r of sine theta, where theta is the angle between this velocity vector and where theta is angle between this radius vector and the velocity vector, or theta is this angle. Okay. This angle is theta. So suppose this angle is theta. So this angle is theta. This angle between between velocity vector and radius vector, this angle is theta. So this angle will also be theta, right? So this distance. So this distance is always r of sine theta. So we can write that m of v into r, that is r perpendicular. We can mention it as r perpendicular. So conclusion. So we see that the angular momentum is constant and is given by m into v into r perpendicular. So now I'll mention another point, that point points to remember or points to ponder, that angular momentum is a property which is dependent on the reference point. It is not an intrinsic property of the system. Property of a system. Example, I'll take the penguin example once again. So my penguin is once again falling with a vertically downwards with a velocity v. M is the mass of penguin. Now I want to calculate with this is my x-axis, this is my y-axis, this is my point P. Now I want to calculate the angular momentum of this penguin with respect to point P. Now angular momentum, I'll just so the angular momentum with respect to point P will be m times r cross v, which is equals to m into r, sorry, m into r into v into sine of theta, where theta is angle between r vector and velocity vector. So now since theta, and in this case theta is equals to 0 degree always, so my m into r into v into sine of 0 is always 0. So my angular momentum for the same system now with respect to point P is 0. So we see that the angular momentum is not an intrinsic property of the system. So now, linear momentum is the intrinsic property of the system, but angular momentum is not an intrinsic property of the system. But yes, if we calculate the angular momentum of a particle which is spinning about its axis passing through center of mass, then it's an intrinsic property. It does not, when a system is spinning around its center of mass, then the angular momentum is an intrinsic property. We'll learn about it in our next lectures. Thank you.